Good day, everyone, and welcome to the webinar for February, where we're going to be talking about Wi-Fi troubleshooting playbooks, runbooks, checklists, troubleshooting guides, whatever term you decide to use for it. But the concept is having a structured troubleshooting process to help us with common problems. And what we're going to do is as you know with me, not just going to talk about Wi-Fi troubleshooting playbooks, but we're going to look at why we should have tools like these, because a lot of people, they're hesitant to adopt something until they see that it's actually valuable and beneficial. So we're looking at interdisciplinary research that shows that these can be very helpful to both experts and novices alike. And so we'll find out how that we go from unstructured to structured troubleshooting processes by utilizing what today we'll mostly call playbooks, but again, you can use whatever term you choose for them that suits your fancy. The first thing that I want to do is begin by talking about how we can ultimately reach the goal of reducing errors. And one of the key factors is the democratization of knowledge, which is not an easy thing to do because we often don't know what we know. In fact, the more expert level our knowledge is, the less we know about what we know, which is really quite an interesting paradox. And what I mean by that is people will ask you how you determine that a particular cause was the cause of a particular problem. And if you're an expert, you may actually struggle sometimes to give the exact procedural details of how you determined the cause of that problem. And this is because of something that we call tacit knowledge. It's a very challenging thing to get out of our minds and onto paper or into verbal communications. So one of the key things that these playbooks help us do is, first of all, reduce errors, because we're not omitting critical steps in the process. And this is not just the process of determining the cause of the problem, but also the process of resolving the problem. So once we have figured out what's causing the problem, we take steps to resolve it, right? And in that process alone, we can cause more damage than the original problem if we forget some crucial step. And then, of course, one of the benefits of playbooks is knowledge democratization. We're reducing the reliance on tribal knowledge and enabling day one performance for the beginners that come in. And then we have cognitive support, offloading working memory to compensate for the 7 ± 2 limit. We'll talk a bit more about that in a bit. Now, I do want to point out one thing here in full open disclosure. I realized that creating slides was a huge part of my time investment in preparing for a webinar. And my general process is to put all my notes and my thoughts together and then to generate slides so I can talk about it. And what I've done is I've let Notebook LM do the work for me. So yes, these slides, if you've wondered, were created by Notebook LM, but the unique notebook that I created had one document in it, and it was all of my notes and my flow and documented sources for this presentation. So amazingly, I had very few things that I had to change afterwards. It's come a long way, which is very helpful in being able to put these slides together quickly based on the knowledge that I've accrued and without having to spend 4 or 5 hours or more to put the slides together. Now, how do we go from this tribal knowledge to systematic proceduralization, or how did we historically do it? Well, interestingly, it all started with just going to the reality of a real problem and then saying, how do we prevent this from happening in the future? And the real problem that started most of this came out of the airline industry, and we'll see that later on. But the big thing we're trying to overcome is this tribal knowledge. And tribal knowledge is not inherently a bad thing. It's a good thing. It's one of the values that we have granted to us by being part of a community, like the wireless community or the Wi-Fi community. We gain much insight from our collaboration with others, our communications and our discussions. When we go to conferences like WLPC and we have our side conversations, or we see a presentation where someone is presenting based on a unique scenario that they had to troubleshoot or a problem they had to resolve, we're gaining that benefit of tribal knowledge. So tribal knowledge is a good thing. But in our day-to-day work, it's important that we find ways to structuralize that knowledge, to make it applicable to others that maybe they weren't involved in those conversations. And it's a lot about bringing tacit knowledge into the foreground. So I've talked about tacit knowledge many times on webinars in the past, but just as a quick nutshell overview, the basic concept of it is it's that expert level knowledge that is very hard for us to verbalize. It's very hard for us to communicate. The analogy I like to give is with a musician, because I play keyboards and pianos and other instruments, and oftentimes I'll do something on a piano or a keyboard, and someone will ask if I can show them how I do that. And when I show them, I do it at the same exact speed as I just did the first time I did it. And I really have to work hard myself as the one who knows how to do it to slow it down and make it demonstrable, because it was a long time ago when I was doing it slowly and initially through many repetitions, developing the speed. And now I don't really think about each individual note that I'm pressing, or if I'm hitting a certain chord, I don't think about whether that's a sustained chord or some other chord. I just hit the chord that gives me the sound that I want. And that's the issue with tacit knowledge. Trying to get it out so that other people can understand it can be very, very challenging. So the paradox between the expert and the novice. Expert and novices do not differ in symptom perception. We see the same symptoms. We see the same evidence. We see the same information that is there at the source of the problem. But experts and novices differ in search strategy. So experts generally use schema-driven decisions. They have, I call it their own internal ontology. They have an ontology, a structure for how things exist and interrelate, okay? They have an internal ontology for how a system functions. And as they gain expertise, that ontology becomes more and more accurate, and it becomes more and more complicated. But it allows them to quickly analyze and resolve problems. Now, I want you to think about this. In any area where you already have expertise, if you pause and think about it, you'll realize that indeed you do have an ontology, how you represent things. Just a couple of weeks ago, I was in a course teaching CWSP to a group of people at WLPC out in Phoenix. And I started off the course by talking to them about the importance of these internal ontologies, because when you're listening to a teacher explain something to you, it's important to know something about how that teacher sees the world that they're talking about. And so I began by diagramming on the whiteboard my internal ontology of security. I talked about information security versus cybersecurity versus network security versus data security, and so on and so forth. And in the process, I diagrammed how I conceptualize these things and how I see them interrelated. And through this process, it gives them an understanding of my internal schema, my internal way of structuring this knowledge. And the reality is that when we think of it in this way, we begin to understand the difference between novices and experts. So an expert is appealing to a more detailed and hopefully more accurate schema or internal ontology of how they see the system. And because they have that and can quickly navigate it, often without even thinking about the fact that they're doing it, they can come to a good probabilistic conclusion of what the cause of a problem is, and can then begin to troubleshoot that problem. However, one of the traps that we can fall into as experts is failing to use meta recognition, meaning that we're not looking at mistakes we might be making because of something that we're overlooking. Or if there's a new thing in the current system that we've not seen before, we may not realize that that new thing's there. It's not part of our schema, right? It's not part of our internal ontology. And so because of that, we miss something that should have been included in the process. That's speed to judgment, right? Quickness of judgment based on the assumed schema that we're working with. And a novice might see that quicker than an expert would in some cases. And there's a lot of research on that interesting phenomena there. But the novice is often playing guesswork without an internal schema that is structured and organized, whereas the expert has what we see here on the right, more of a structured path that they can go through. But meta recognition becomes important to them as well, so that they're evaluating whether that schema still applies or not. So the expert will often also use different paths to a solution. We find that experts have a tendency toward appealing to colleagues rather than documentation in many cases. There's a lot of research on this as well. And so they will go through the path to the solution by consulting with experts that they know, whereas novices will tend to go to documentation or tools. Now, if you just think about it for a moment, there's a very good reason for this. The novice doesn't have as big of a relational network. They're just beginning, right? Whereas the expert has more of a relational network because they've been in the industry. And when I talk about developing expertise a lot, I talk about the importance of community. And we do find that the vast majority of experts have a well-established community around them, whereas novices don't have that yet. So it makes sense that they wouldn't appeal to that as often. But it is interesting that research shows that in a workplace environment, everyone, regardless of their level of expertise, prefers to query a colleague before documentation, which is not necessarily a bad thing. Because if you work in an environment and you are an expert, a colleague may know about some changes to that environment that you don't know about yet. And if you're a novice in that environment, a colleague may know of unique things in that environment that you don't know about because you're new to that environment. So checking with colleagues is not a bad thing for anybody at any level of expertise, of course. Now, it's interesting, these things we call playbooks, they go by different terms depending on the industry you're in. In aviation, they'll call them checklists or quick reference handbooks. In medicine, they might call it a care bundle, a clinical pathway, or a cognitive aid. Within technology, we might call them a troubleshooting guide or a runbook. In cybersecurity, they might call it a cacao. I'm sorry, I just always have to say it that way. But that's a standard for it. I'll talk to you more about that in a moment. A course of action or a playbook. In enterprise, they might call it an electronic performance support system or EPSS. There are all kinds of names, but ultimately they're all the same thing. And you've heard me talk about this many times before. If you've been with me in webinars or in classes or in presentations, it's a checklist. Ultimately, and it might be a fancy checklist with all kinds of extra information, but it's a checklist. Now, again, as I said, it was born from failure. In 1935, there was a B-17 crash, and this caused them to step back and say, we've got to figure this out. Initially, they said, oh, it's just that this plane is too much for one person to fly. But then they realized that using read and do or challenge and response, they can improve this. Interestingly, it was found through research ongoing and reported, as I reference here, in 1993 in one particular research, that challenge and response is more effective than read and do. So read and do is a one-man or one-person operation. Challenge and response is a two-person operation. So with read and do, I take the checklist and I go down the list checking things off. With challenge and response, I don't hold the checklist. Someone else has it. They're reading it off to me, and I am responding to it. That challenge and response mechanism was more effective at reducing safety violations, errors, and so forth than read and do. It's not always possible in real-world scenarios within technology, but it is an interesting thing to keep in mind. Why do we know these things work? Well, some of the most important areas in the world, like healthcare. The World Health Organization Surgical Safety Checklist, for example, reduced death rates by 47%. Complications went from 11% down to 7%. We have also found this in technology. So researchers within Microsoft did a large-scale study of 4,000 troubleshooting guides. And what they found was that for severity level 1 incidents, which was better than 80% of their incidents, severity level 1 incidents went from 36 hours to 2 hours if there was a troubleshooting guide for that particular incident. So incidents that had troubleshooting guides were reduced. Now, they didn't mention this in the research paper, but I felt it was an important thing to contemplate. They didn't mention the reality that maybe, just maybe, some of the incidents that didn't have troubleshooting guides were very complicated, and there was no troubleshooting guide because they were also very unique and uncommon. That is to say, we tend to create troubleshooting guides or playbooks for things that are common. 90% of the problems, for example. We create playbooks for all of those. But the other 10%, they don't happen as much, and maybe all of them in that other 10% happen once a year or once every 2 years. So there's less likely to be a playbook for it. And in addition, when there's less likely to be a playbook for it, it's also likely to be a more complicated scenario that takes longer to fix. So we have to keep that kind of thing in mind, and I think that could impact this. But even if we didn't have this huge 34-hour disparity and it was only a 4-hour disparity, it would be a significant benefit to have the playbook over not having a playbook. Also, it's important to note that use of playbooks needs to be considered. Are people actually using them? The key factor in their use is their availability, how available they are to the individual. So if it's readily available, particularly if it's integrated in the system, then we will implement these playbooks accordingly. One of the key factors that was found was brevity. We want to have the playbooks be concise and to the point, use imperative language, incorporate decision logic, meaning using decision trees over just flowcharts, having content sensitivity and interdisciplinary creation. But one of the key things is managing cognitive load. Cognitive load is how much you can retain in working memory. It goes back to Miller's Law from 1956, the 7 plus or minus 2 rule. Why does this matter? Well, it matters because we have to balance the benefit we get from the checklist with the cost of using the checklist. I'm not going to get into this formula in great detail, but you can come back to the video on YouTube later on and review it if you desire. The key factor to know is that it is possible to reduce the benefit of a checklist by the fact that it's such a simple problem that a checklist shouldn't be needed. At the same time, we have to remember who's evaluating whether it's needed. If it's an expert evaluating whether it's needed or not, then the reality is that there are going to be more things they think are unnecessary. But if the reality is that it's novices evaluating whether it's needed or not, there are going to be more things that are necessary. So we certainly have to keep that in mind. The key then is to make sure that the diagnostic accuracy of a problem is higher with the tool than without the tool. And it was found in 29 studies that checklists do not cause expertise reversal, which I think is an important thing to know about. Expertise reversal means that we're losing our benefit of being an expert because of using checklists. So this goes back to the fact of, if I'm an expert, is it worth looking to see if we have a playbook for this particular problem? Because after all, I'm an expert. I can just jump in and fix it. And what the studies found is that there was no expertise reversal, which means that there was no increase in time to resolution for experts by using the playbooks. Again, that's a general number, and there may be certain scenarios where it would cause expertise reversal. The taxonomy of these playbooks is that we can have static parallel, which means that it's the read and do, right? The individual going through the checklist. We can have team verification, which again means that now someone else with a challenge response is reading the checklist and we're following it. They can be static sequential, which just says do this, then do that, then do the other, or they can be a dynamic algorithm. So the static sequential is more like the flow chart. The dynamic algorithm is more like the decision tree. The decision tree is ultimately going to be the implementation of algorithmic logic. So we'll have an instruction, we'll have a decision point, a decision block, and mapping logic, just like you would in the logical construct of code. And then we have our integration levels. And this is one that I really want to emphasize. We want to think about how we integrate these playbooks into our processes. They can be external, extrinsic, or intrinsic. External would be a web page we go to get it. Extrinsic would be within the system itself, there are pop-ups or overlays, and intrinsic is that where you're actually doing configuration checks or configuration changes, they're built in. Obviously, it's mostly up to vendors to make it intrinsic. And it's up to us, in some cases, to make it extrinsic. And I think we'll see this adapting more over time, because with the capabilities of modern systems, you could have a browser window open for an HTML-based configuration interface, for example, where there's a side browser window that is reading your browser window with artificial intelligence. And then it's finding playbooks related to what you're looking at. That could make them extrinsic. They're still outside of the system, but they're made available within the overall interface you're using to troubleshoot the process. Now, why did these tools fail? According to the research paper from Microsoft's team, they gave us these top reasons. The most common reason is completeness. They don't have all the information needed in the playbook. They have broken links. They're linking to either an interface to change a configuration or other documentation, and the links don't work. Correctness, like for example, having 2 C's in correctness. The issue is making sure that they are correct, or having correctness twice. You get the point. Readability, I left that in there when Notebook LM did it for that very specific purpose. Readability and user experience were important. Empty content, literally having a playbook go to nothing because we didn't finish it. Outdatedness, it is old information that no longer applies, or relevance. It does not apply to the current situation you're troubleshooting. So how do we go about creating these? Well, there's a detailed process here. I'm not going to go over it in lengthy explanation, but of course you could always go to the archive on YouTube and read this 8-step process, which is based on the research from the Microsoft group. Barriers to adoption include fragmentation, ego, meaning experts say I don't need these things in many cases, or fatigue. And where are we going with this? Well, I think one of the key things is automating because of playbooks. That is, if we've documented the different ways that we can implement these playbooks and troubleshooting processes, then future systems can be developed that automate much of the process. That is to say, if users can't connect to Wi-Fi, then we can say, okay, let's automatically check some things that can cause this, such as the configuration of supported physical layers versus what the client supports and other such parameters. So we can actually have it go through the process of validating some things according to our playbooks and giving us output that lets us know what has already been checked versus what we need to manually check. And again, there is a standard that is available that you can look at to get some input and ideas. related to developing your own playbooks. So the reality is that the Cacao standard is an OASIS standard. And if you've not seen what OASIS does, they create a lot of process standards and things like that, and document format standards. And that's what this is. It's a standard for creating machine readable. In other words, text-based documents that machines can read to understand the playbook. And it's specific to cybersecurity, but there's a lot to learn that could be adopted for other systems. All right, what I want to do now is take you into a couple of examples of these kinds of playbooks that can be utilized for these procedures. So fittingly, within the CWAP process, we have the digital edition of our study guides now. And so one of the things we do, and a lot of people don't realize this, but we actually update these throughout their life cycle. So it doesn't always stay the same as what it was in the beginning. We do have notifications. So I should point that out to you. If you have access to these and you go into your preferences, you can see in your preferences, there's a notification preferences section. Just make sure that you don't disable notifications unless you don't want to receive them anymore. And then further down, you will see specifically course content changes. If you don't want any of the other notifications, you can deselect them all and then just keep this one selected. And basically, anytime there is new content that is added to the digital study guide, the e-learning, whatever you have access to, it will automatically update you. So for example, I decided rather than just creating the playbooks and talking about it in the webinar, I would go ahead and put it inside of the CWAP Digital Edition Study Guide. So it has received an update as of last night. And I sent out the notifications earlier today. So when we come down here, there's a PDF example of a playbook. So this is a playbook specifically for the symptom. User says, I can't connect to the Wi-Fi, right? This the simple thing that we face. But is it a simple problem? Well, we've got a 12-page playbook here with several decision trees that are used in the process of troubleshooting this scenario. Now, again, anyone that's with me today that's an expert, I hope that you would know all of these things to do and more. But keep in mind that these are not just for experts. And even an expert can get rushed and forget certain things. So when we take a look at this, you'll notice that we have a master decision tree here. And the master decision tree starts off saying, well, the user can't connect to Wi-Fi. Is the Wi-Fi adapter enabled? First thing you check, right? No, enable it. Yes. Can they see the target SSID? No. Well, what are we going to look at if they can't see the SSID? We're going to check the client radio, driver issues, and so forth, and notice there's a branch available for that. So if we go down further in the document, you will see here that we have the driver issue branch. So we're checking if the driver's up to date or not. We are going to check to see if it supports the appropriate band. We're going to forget the profile if we need to, if it's become corrupted. And we're going to see if there's a third-party tool set or supplicant on the machine. So the point is that it's guiding me through the process. We're going to look for the things that are most common. And I just came up with these percentages off the top of my head. They're not based on research per se, but this could be statistically based on historical trouble tickets within your organization. Meaning that when someone says, I can't connect to the network, you find that 63% of the time, it's just because they've disabled their Wi-Fi adapter, right? So you're actually able to go through that process. And then we've got the process for the most common to the least common. So as we go down through, they become less and less common issues that you would have to actually address. And that's generally the way that you want to do it. Now, the PDF is one way to do this, but within your organization, you might want to consider doing it through a web-based interface. The nice thing is that you can do exactly what I did to create this interface, which is I first of all created the document, typical Word document. And then what I did is I gave it to an artificial intelligence tool and said, generate an HTML interactive interface that allows me to provide this playbook to other individuals. In other words, I don't have to create it all from scratch. I can have it generate it for me, and then I can fine tune it, tweak it, change it, adjust whatever I want to, so that we can accomplish this. So what we've got here is cannot connect to Wi-Fi. And the first thing we want to do is say, can the client even see the SSID? And again, there might be novices, right? So how do they do that check? It tells them for different operating systems, specifically how to do the check. And then they can also check the wireless LAN controller logs. And based on whether or not they can see the SSID, we, of course, will take different actions, such as verify the AP is online, verify the client radio is enabled, make sure the client supports the bands. If it's an authentication phase problem, then maybe there's something wrong with the profile, right? So we can go through the steps to see how to forget a network. All of it provided within the tool. DHCP and IP assignment. How do I check IP addresses? Well, here's how you do it on Windows. Drop out, do an IP config/all. On Mac OS, you have the ifconfig. You also have special keystrokes you can use with the Wi-Fi icon to see more info. In Linux, you can use the IP adder command or the ifconfig command if it's there. And on iOS, you can use various methods as well as Android. So again, it provides for different clients these different options. Now, you know your environment. So which of those environments do you need the commands for? That's what you would provide, right? And then the final thing is DHCP. So maybe we're getting through authentication and association. And of course, this is authentication and association here. This is the post 802.11 authentication association. This is the either pre-shared key or 802.1x radius authentication. And then here we have, okay, we got past 1 and 2, but we're still not able to use the network. And quite often that's the case, right? It's quite often that when you get onto the network, Wi-Fi is working, but there's a DHCP problem. And so the focus here is on verifying that. And of course, you can check the IP address. And if you see that you're getting an APIPA address, then that's telling you that you tried to get an IP address and you got no DHCP response. And so it assigned one of the 169.254 addresses. You can also see if you have no IP address, then there may be something else wrong where your client's not even trying to get an address. Or if you look at your IP address and see that you've got an unusual address for your environment, then maybe it's that someone statically configured that device and it needs to be reconfigured. So this is just the cannot connect problem, right? We also have sporadic performance problems, where now we're going to be looking at signal strength. And we have instructions for how to check RSSI on different platforms and what's available to do so. Channel utilization and interference, capacity and client load. What about roaming issues? We can verify cell overlap. If we have 802.11r, what's the status of that? Is it a layer 2 versus layer 3 roaming problem? For sticky clients, what might be the issues causing that? For resource access, once connected to the network, is there a VLAN or subnet problem? Is it DNS or gateway issues? Is it ACLs, firewalls, captive portals? I think you get the point. So the issue is that we can actually create these types of interfaces from our documentation. Now, the key is you may already have this documentation in your environment. So if you already have, excuse me, if you already have within your trouble ticket system something similar to a playbook, it may not even exactly be that. It may not be a flow process or anything like that. With the power of generative AI today, you can take that data and in a short period of time develop an interface like what we see here and then make it available to other people. But the key is you as the expert can sit there generating the interface, validating that things are correct in what has been generated, right? Making sure that you're not developing something that is inaccurate or that maybe is not ultimately unique or beneficial for your environment. So you can customize and tweak exactly what is being implemented in the system, but not have to do it all from scratch necessarily. Let the AI generate it for you. Then you can, do second shot, third shot, fourth shot with the AI to get it to fine tune it. Now, as you all know from previous webinars with me, if you've been with me, my preference is Gemini and the Canvas for creating these kinds of interfaces. But you can use whichever tool you prefer. If you like Claude, if you like ChatGPT, it's hard for me to even get that word out of my mouth anymore. I'm not a huge ChatGPT fan in the modern era. If you like Perplexity, maybe, or some local Olama-based solution, the point is that let it help you generate it. And then, again, through multiple shots, you could often go back in and get the details that you desire. And sometimes, I'll be honest, you can't. You can't get it to fix certain things the way you want to. And what do you do then? Well, you go into the source code and you customize it, tweak it in the source code in the way that you need to make it meet your needs. But you can get at least the majority of the work done in providing a tool like this to your novice and intermediate professionals so that they have a process to go through. And interestingly as well, you can actually take it a step further and make it so that the users of the tool or the interface can actually go in and tweak it to their level of expertise and knowledge. In other words, they can choose what level of detail they want to see. They just want quick hint reminders. Do they want the more detailed information? Sometimes as people reach closer and closer to the expert level status, all they need is a real quick schema verification to remind them of things that they might be missing because they're overlooking certain things, and they don't have to see all the details. They don't need the extra, what to them is clutter that a novice might need, but to the novice, it's not clutter. It's the details that are needed to help them resolve the issue. And so the reality is that you can enhance these processes in that way. Now, to be clear, what you're looking at is in the digital edition study guide, but hey, this is a public free webinar that everybody is available to attend, and it will be a recording on the CWNP TV YouTube channel. So just so you know, there will be a blog post at CWNP that includes a zip file where you can download both the HTML that we just looked at, but also the PDF of the playbook. So it's incorporated in the LMS, in the Digital Edition Study Guide, but I'll make them available to everybody in this case because it's something produced through the webinar. It's just one of the processes that I'm doing is that I am, as I create things for webinars, if they're applicable, I'm going to be adding them to the Digital Edition Study Guide. So they're just available in there for people that have acquired that. However, you should know that there is a code that will be made available to you at the end of this webinar after we stop the recording, where you can get the CWAP Digital Edition Study Guide for 50% off. So that's something that it will be an option to you as well if you don't already have that. Okay, so what I want to do is jump back over to the slides and go to this last one and talk a little bit more about where I think things might be going. Now, I wasn't happy when Notebook LM put AI Copilot into the graphic that it generated. And the reason I wasn't is nobody's using Copilot. There's actually a whole bunch of press that came out just in the last week that people aren't using Copilot. So they've got Copilot built into Windows and they're not using it. They're still using ChatGPT or Gemini or something else. And so, the reality is the vast majority of people are not using Copilot. But I don't have anything against Copilot myself. But if you're using it, great. The big point I want to make is I'm not saying that Copilot is the future of what people are going to do with this. What's intended by this AI Copilot concept is that you have exactly that. You have a Copilot. You have someone along with you, like, for example, where the terminology comes from, right? Going back into our history of where this came from, right here, right? The challenge and response model. The challenge and response model is the most effective use of playbooks rather than read and do. So I said earlier, in technology, that doesn't always fit, right? In technology, you're one person there troubleshooting. But wait a minute. Does the Copilot have to be a person? No. The Copilot can be AI. Now, we're not going to trust AI. Back in 2022, there was actually a book put out by, if I remember right, it was Springer Publishing. It could have been River. But anyway, it's called Toward Trustworthy AI. And the big issue they're addressing or dealing with is the fact that we all know we can't trust generative AI. We simply can't. Instead, we have to verify, right? And we can't even say trust but verify. Instead, we should say verify, don't trust. It's more weightier than trust but verify. So we have to say verify, don't trust. And that doesn't mean that AI is not beneficial, though, right? So AI can be helpful, like the fact that I was able to have it generate slides based on my notes rather than me having to create all the slides manually, which means that I can get more content together for a webinar with less amount of time for developing the artsy stuff. And Tom's not that great at the artsy stuff anyway. So the benefit in the context of these troubleshooting playbooks is that if we're creating these over time, when we get to the point where we can feed them to AI tools, and we're actually already at the point, but systems are still being integrated. When we get to that point, then while we're working on a troubleshooting process, they're there to help us. Think of it like vibe coding, right? So if you're not familiar with vibe coding simply means that we are coding and we've got an AI tool that is helping us along the way, right? So we might get to the point where we need a particular function, and rather than creating it from scratch, we jump over to the chat and say, write a function for me that does X. And then we might tweak and tune the function that it creates, or we might go back to the chat and say, oh, change this about the function, and let it change it. The point is, we're coding with AI. Well, why not be troubleshooting with AI? Where that we've got this Copilot that when we look at a log, we're not the only ones looking at it. The AI is looking at it as well. And the AI is telling me things it's seeing in the log that it thinks are relevant. And I might agree with it, I might disagree with it. But the point is, I have a Copilot. Because I have a Copilot, I'm not alone in the process, but there's a challenge and response procedure that is being implemented, which, again, through research, we know improves the troubleshooting process. So I think this is a valuable potential future. Again, the issue with this is to have it integrated in such a way that it doesn't matter what I'm using to look at the logs. I could be using a tool built into my wireless management system. I could be using a text editor. It doesn't matter because the Copilot is just reading my screen. It's looking at my screen, doing OCR against what's on the screen, if necessary, looking at graphics and diagrams on the screen and so forth. So the point is that it's watching what I'm doing and it's giving me feedback along the way for things I might have missed. But how is it determining the things I might have missed or the things I need to be looking at? Because it has this resource that has been trained on, which is our playbooks. Now, I want to be clear with you. I don't think we should use things like ChatGPT, Gemini, etc., these online frontier models where we're sending our screens as we're working with our network infrastructure up to the web. That's way too big of a security risk. But what I do see is a future where we've got our local open source based large language models that are driving tools like this, where the data is never leaving our network, it's staying within our network. And we will have the security concerns with all of those, because someone can attack our local install of a large language model, and they could then inject into it data that would cause us to take actions, particularly if we're novices, that we shouldn't take. So there has to be caution with all of this, but I'm just illustrating a potential future. I don't think we're completely ready for it yet due to cost of implementation and the knowledge and skills required to implement such a thing for most organizations, but it's something that's in our future. And the possibility also of SLMs, small language models that are trained and fine-tuned specifically for this kind of a process, means that they can be implemented with much lower processing load and still accomplish our end goal. So I think there's a lot of potential there for that in the future. And I think this is where I see it going. But guess who will be ready to use it best? The ones who've taken the time to document everything. So when I say everything, I mean documenting the internal ontology of your experts. One of the greatest challenges we have within knowledge management in organizations is getting tacit knowledge out of the minds of our employees so that it's available for all employees. So what I would suggest is now's the time to begin that documentation in organization. And we want to be defining this knowledge that's in the mind of our experts and in the mind of our novices alike, so that we can utilize it. And playbooks, documenting the steps required to troubleshoot a process, is something effective. But the key is going to be security along the way. As everyone knows, when they hear me talk about security, security should be pervasive. It should be cross-cutting. It should not be something that we do when we start programming a system or when we start implementing a system. It should not be something we do when we design a system. It should be something that we're doing from the very moment when we just begin with business requirements, before we've ever even gotten to stakeholder requirements. All across the journey, from inception all the way through to implementation and support, we should be including security in that process. So it should be a cross-cutting process that is always there and impacting every decision we make along the way. And obviously, this is, for obvious reasons, wildly important with large language models.